Question 6b. They've given me a diagram. Okay, and they've told me some information. The only thing extra that I'd like to fill in here is that this is 90 degrees here, they said, which automatically makes this one 90 degrees because vertically opposite angles are equal. I've labelled this X. I have put in, you know, they put in the 3 and the 5 for me, so everything else is in there. And they said, the question is then, from there, they want me to prove that PO times the length of RS is equal to the length of OS times the length of PQ. And, you know, for just kind of filling in everything into my own diagram here. You know, it's the same, but I just wanted to see if I could figure anything else out, maybe from sketching it out myself. And what I do notice is that because I have parallel lines, I have alternate angles. So I've marked in my alternate angles here with little dots and here with the little tick. And I often prefer then to actually, like, even though my triangles in my diagram, they're facing each other, or, you know, they're not looking exactly the same, I often redraw them so I know exactly, because I now see that I have similar triangles, which sides match with which sides. So you know, I don't usually find it as helpful to look at it like that as I do to draw them out myself and look at and compare them, and then know that if I have similar triangles, well, this side over this side is equal to this side over this side. Okay, so they want me to prove this, and from my diagram, like I just said there, OP or PO over OS is equal to PQ over RS. I'll just show you that again. So once I have my right angle and my right angle and the two little ticks here and the dot here, I can know that OP over OS is equal to QP over RS. Okay, and from there I can just cross multiply and I'll actually end up with exactly what they want. Sorry. Times RS is equal to PQ times OS, which is what they wanted me to prove. So that's the first part of it done. The second part then, they want me to hence find the area of the triangle in terms of x. So area of a triangle, area of a circle, pi r squared. So this is part 2. Now, they want me to find it in terms of x. So, going back to my diagram here, what I notice is that because this is a right angle here, this must be the diameter. Remember, you have a rule in your geometry saying that if the diameter, if you draw a triangle that touches the circumference on the diameter, then the angle here is a right angle. So we're just using the converse of that. If the angle here is a right angle, PQ must be the diameter. So if PQ is the diameter, well, then I can use the information from up here. And so I can see that PQ is equal to PO times RS divided by OS. And I'm just going to start filling these in. So PO is 3, RS is X, and OS is 5. And that's the length of PQ. Now, none of my formulas really have diameter, so I'm going to replace this with 2 radiuses. Is the same as 3x all over 5. Therefore, the radius is equal to 3x all over 10. I'm just going to fill into my formula, pi r squared, pi times r squared. That gives me pi times 9x all over 100, which is just 9x squared times pi all over 100. That's the area of my area of my circle in terms of x.